In this question, we'll use the concept that the frictional force is a self-adjusting force. Therefore, the change in the value of the applied force P will result into the change in the value of frictional force. Let us first find out the forces acting on the block. mg sin theta will act in downwards direction along the inclined plane, and the force P will act in the upwards direction along the surface of the plane. It is given in the question that tan theta is greater than mu. Therefore, the block will have a tendency of sliding downwards. Hence, the frictional force will act in upwards direction along the surface of the inclined plane. It is given that the block is held stationary by applying a force P parallel to the plane. Balancing these forces, we get mg sin theta is equal to P plus F. Now it can be very clearly seen from this equation that when P is equal to mg sin theta, F is equal to 0. Now, when P is less than mg sin theta, the maximum frictional force can be mu mg cos theta. So, the minimum value of P for the block to remain stationary can be mg sin theta minus mu mg cos theta. As the force P increases, the frictional force will decrease and will be equal to 0 when P is equal to mg sin theta. In this case, the block will have a tendency to move down, so the frictional force will act in the positive direction. As P will increase, the frictional force will decrease and will be equal to 0 when P is equal to mg sin theta. Now taking the case when P is greater than mg sin theta. The maximum value of P for the block to remain stationary can be mg sin theta plus mu mg cos theta. In this case, the block will have the tendency to move up, so the frictional force will act in the negative direction, and the block will remain stationary till P is less than equal to mg sin theta plus mu mg cos theta. When P is equal to P1, that is P minimum, the frictional force is maximum in the positive direction. As P moves from P1 to P2, the value of frictional force decreases. That is, when P will be equal to mg sin theta, frictional force is 0, and when P is equal to P2, that is P maximum, the frictional force will be maximum in the negative direction. Therefore, the graph in option A depicts it correctly. That is, option A is the correct answer.